From Central Point, Oregon, headquarters of Microvellum Software, this is Microvellum Live. Thank you so much for being here today. If this is the first time that you've joined us here on Microvellum Live, we host these free episodes weekly to educate, inform, and inspire our users and those who are interested in learning more about our software solutions for the woodworking industry. If you want to catch up on any of our live episodes, you can find them all on our website at microvellum.com/live. And today you have a couple different ways you can participate in this episode. You can chat with us using the chat window here in the Zoom that you see there in the Zoom navigation bar or in our YouTube live stream. And if you have a specific questions, be sure to use the Q&A UI here that you see in Zoom, and we'll make sure that your question is answered. And as usual, we are recording this, so you'll be able to catch up on this a little later on microvellum.com/live. All right, today we have a great episode lined up for you today. We've invited Ralph Butler back, a longtime user and service provider and now current account rep out of Virginia. So welcome, Ralph. And we've also invited Chip Cappelletti as well as Rob Curtis from Cleora Sterling to join the conversation. So welcome and thank you both for taking the time to be here.
Our pleasure. Thanks for having us.
Yeah. So Ralph, when we were discussing this week's episode, we decided we wanted to spotlight how our users can build more than casework and kitchen standard boxes with their Microvellum software. Obviously, we have a lot of customers that are already doing that and building beyond the simple cabinetry, as today's topic is, our episode is titled. But we wanted to dive into a discussion into this topic a little bit more. A lot of the companies that we speak with these days, they're feeling the pressure to build more and to venture out into bidding on projects that they might not have considered in the past. So I'm glad we're taking the time here to highlight how they have a tool in their Microvellum software that enables them to take on this type of work confidently. So looking forward to how this develops.
Yeah, me too. We have a lot of folks out there that do various types of millwork using the software, and a lot of people don't realize just how much you can do with it.
Right. So remember, for those of you watching here today, if you've got a question for myself, for Chip, for Rob, or Ralph, feel free to ask it at any time, and we'll be monitoring your comments along the way. So, you ready to get into it, Ralph?
Sure.
Awesome.
Glad everybody could join, whoever's here. Numbers increasing as I watch the attendees coming in. Being joined by Chip Cappelletti, the owner of Cleora Sterling, and Rob Curtis, lead engineer there. So glad to have both of you here. Thanks for taking time, guys.
We appreciate the opportunity. Yep.
So we were talking earlier, and Rob, you had some pictures and stuff like that of this one project that we're going to talk about on your machine. If you want to show your desktop, you can go right ahead and do that. This is a project that had a lot of ornamental millwork in it. Chip, why don't you describe some of what took place here, what this is, what work you guys do?
Okay, so this was the Holy Name of Jesus Cathedral, a Catholic church in Raleigh, North Carolina. It was a huge trim project for us. All totaled, at the end of the day, we calculated about 22 miles of running trim. All the trim was painted, so we used a variety of poplar and MDF, depending on where it was going and what we were trying to do with it. Wow. And while the scale was enormous, even throughout the whole building, there were column lines and trim lines at 70 and 80 feet. By far, the biggest challenge we had was the dome itself. And the dome was approximately 40 feet in diameter. It started at about 70 feet off the ground and ran about to 160 feet off the ground. Everything was done off of lifts. It took us literally 10 minutes to get from the ground to the top. We had Oculus trim that sat at the top of the dome, and then 6 rows of crown molding. So think, angled trim in a circle. Very difficult to do. In fact, we were trying to talk the owner and the architect into doing it out of flex mold, which would have made our life a lot easier, but they prevailed and they wanted it out of wood, and that's what we delivered. Rob will go into a lot of detail about how we did that, and I think, Ralph, you're going to talk a little bit about how it might be done a whole lot faster in today's version. We're on the 6.7 version of Microvellum. So we were doing a lot of this by hand and then nesting it in there. There's the dome itself. You can see the top oculus, which is 10 feet in diameter on the inside and 14 on the outside. And then if you go down those purlins, you'll see a number of rows of crown molding that actually had to be coped back in. It took us 2 months to install all of that trim you're looking at.
Wow.
The large crown molding that's just above the lights, that is 17 pieces that go around, and each piece weighed 100 pounds. So it was a lot of work, very high up. We're probably 80 feet off the ground at that point in time. We used some framework that we made that we bolted in and then attached the moldings to that. Rob will get into a lot of those details for you today. The project started in January last year, and we were done by June.
Man, you and I have known each other for a long time, Chip, and you guys have been using Microvellum to do casework and stuff like that for a long time. And when I learned that Rob used Microvellum to do a lot of the work that was here in different types of ways, different ways of using the application, I was pretty impressed, and we're going to get into some of that. So the oculus is that piece that's way up top, that circle, kind of like an eye up there above the purlins, and I think I pulled a piece of that, a section of that out of some of the drawings he's got, and I've prepared something to show you in the newer version. But yeah, we're looking forward to seeing what Rob did to do some of this work.
Yeah, and even that top oculus, even though it's almost flat up there, almost only counts in horseshoes and hand grenades. So it's on a slight radius as well. I think we'll have some pictures later on to show you. So it was all pretty challenging for us.
Right. Yeah, the thing that I did, I didn't go that far. I'd only had about a day and a half or so to prepare for this, along with a lot of other things. So, I guess most of the work, in drafting the section, he did all that, and I just robbed that section out and did a few things to it to use the extruded product builder to create the framework and some of the moldings. So go ahead.
All right. So let me see if I can find a couple pictures here of the individual components. Not sure if I've got them handy.
If you have something that shows basically, it laid out in the floor of the shop and stuff, that'd be great.
That's what I'm trying to find real quick. Well, here's a picture of that oculus as it left the shop floor. It's plywood ribs and stacked MDF trim. The outer bands, I believe, are kerfed MDF rather than bent plywood. The moldings are stacked pieces of flat radiuses that we had to determine the proper radius for once it was bent into a cone shape. I believe one of our previous engineers' favorite word here was frustrum is the name for that geometrical piece.
Right.
Frustrum is correct. You must be talking about Kurt.
I am.
Yeah, of course.
Lovingly. There are some others. Trying to get to the sections of crown. Apologize for not being more organized with the pictures.
We had them in chronological order, but when we shifted them to the server, somehow they decided to resort themselves. One of those, can't explain it, don't really know why, and so here we are.
So Chip, while he's looking for the pictures, you told me that a lot of the profiles were used in the oculus and then some of the trim up in the dome were also the same shapes that you use in different ways throughout the rest of the church. Is that right?
Yeah, we mixed and matched a bunch of different knives that we had here to actually get what the architect wanted. The interesting thing, even though some of these look very similar from top to bottom. They used a lot of perspective in their drawings, and they actually changed the size of the crown molding as it got higher. They made it a little bit bigger. So it was challenging to, you know, not spend $20,000 on knives. But our guys were pretty resourceful, and between combination of shapers, you know, with tilting augers as well as the molders, we were able to reuse a bunch of knives in a bunch of different applications.
So let's go ahead, Rob, and we can look at your drawings within Toolbox if you want. The crown that you put in there was a multi-piece thing that was 22 inches deep. At least the piece I grabbed a hold of was about 22 inches deep. And tell me, what did you, I know you had to form up the crown, and you stacked up pieces of MDF, glued them together, and then run the tilt shaper on these, and you had to cut the ribs and the cleats and the stretchers and all this other stuff, the rails. You had to do all of that. And so is that what you used the program to do, to lay out your nests and all that kind of thing?
We used Microvellum as our sole link from drafting to machine language. So anything we had to cut on our Onsrud router was run through Microvellum to actually produce the G code for the cutting sequence. Due to the sheer number of parts of this, I ended up hand nesting most of the arcs in an effort to conserve material. Our version 6.7 doesn't have the capability of doing true nested stuff, so it always wanted to nest as a rectangle. So I actually ended up nesting these things in groups as nested rectangles on a single sheet, and then cutting those to shape and then stacking those parts for the actual molding on the tilting edge shaper.
So to understand it, you modeled this thing in 3D and then exploded and took regions and placed them into the nest. Is that right?
Actually, we went straight from the 2D section drawings. Once we received the actual field dimension radiuses, since they may have changed slightly from the design drawings, and developed the curves from those 2D drawings right in AutoCAD. And then simply took those objects and moved those onto a sheet and applied machining to them individually within Microvellum.
How long did it take you to go from section to a nested sheet that would produce code?
I could usually run a specific band of crown, and if I remember correctly, I think there were 17 bands of crown from the floor to ceiling of the oculus, of the dome itself. And I think it took me somewhere between 8 and 12 hours per band to get all the bits and pieces needed to make a single layer to the Onsrud.
So you're talking about after the section was drawn, going from the section to creating those things for each band was 12 hours or more.
Correct. And that was stacking each individual part from the section as a different offset radius, and then labeling each and every part so that the machine operator could transfer those labels and get these parts restacked at the end in the right sequence.
So this is the drawing that I took. This is what I took out and put, and you and I haven't talked about the details of what I did to your drawing, but this drawing right here that you are showing us right now, this is something I want to talk about for a second. So when I'm thinking about doing millwork or something that's not a cabinet or whatever, using Toolbox, if it's a custom product or fixture or a piece like this, like a multi-piece trim that's going in, then I'm trying to think about a few things, like what is it that I need, what can a program do for me to help me in getting this work done? And what is it that I have in the shop that's automated that I can make use of, that I can, get an advantage out of? And I think you did an excellent job. You took the kind of approach that I have in the past, and I'm not trying to ride in on your work because I've done things that were, like windows and entry doors and stuff like that. I haven't done a lot of what you're doing right here, but I think that you were very creative in being able to think your way through, how can I use a program to get the information I need to my router and use my automated manufacturing tools out in the shop to quickly, as quick as possible, get what I need to then put together in a manual way and then use that offline machine like a tilt head shaper or whatever to get the designs that I want. And I think that you did an excellent job in doing this. So, you know, kudos to you. This was great. You had to really think your way through this process.
It was a long time.
I'm sure.
It seemed longer at the time during the period.
So going back in review then, to go from this drawing right here where you've got, you know, layers of material, MDF, that you put together, and plus you had to size this to get the, because I know that there's a couple of pieces in here that are smaller than the rest of them. Some of these are 1 inch and others are just under 3/4. So yeah, they're 0.748, I believe 2 of them are, J and E. And then the rest of them are all 1 inch. And I know that because I had to go in and create some components within my program in order to duplicate what you did. So what I'm going to do is show you, I'm going to jump to my screen right now for just a second and kind of show you what I did here in the version 7 platform. It's actually version 15.5. And I'm using the build 1505 or 1501. Yeah, 1501. And this is a whole several generations beyond where you are now. And we have tools in here that you don't have in your current version. I know you guys are planning on moving up, but what I'm going to do is open up a project that I created beyond for today's demonstration or today's video, or meeting, or whatever you want to call it. So I did prepare some of this, and I wanted to make sure that I was able to do the work that in this part, using these tools that you did there, and illustrate kind of what I did. So these are 120-inch radius circles, and I trimmed these bits out because I wanted you to be able to see the edge of this. I know yours went all the way around, and then you would have broken it up in segments, but this is the components in here are going to get broken up in segments based on some parameters that are set up within the smart layers of Extruded Product Builder. This is a polyline, and as I said, I trimmed this out strictly for visual so that it makes it easier for us to see. If it was completely closed, you wouldn't be able to see the kind of thing that I want you to be able to see. So I brought this drawing here in, and I'll stretch over. And this is about what we were looking at on your machine. It has French cleats to hang it with, it looks like. And I'm not going to pay much attention to this back part here, but I have rails, you know, brackets are in the middle here that are your plywood pieces. I made everything out of MDF, I think, just for simplicity. It would be too heavy. I think plywood would have been a lot lighter. These are those stacks. So I'm going to do one of these circles is going to have the stuff that you're going to run the tilt shaper on. And this other circle is going to be the finished product. And if you went out, Chip, you said earlier that you had tried to talk them into using some flexible moldings. And if you were able to buy flexible moldings that were this size and style, then maybe you wouldn't have to do this other one where you were stacking this up, gluing it and shaping it. You could just do the one circle, and then it could give you linear footage of the finished molding. And so you can see how that would work as well. But for the visual part, just where you could get, you know, a submittal to get somebody to approve it or whatever, or to get the concept so that the people on the shop floor could look at this and see what the finished product would look like, this would be a good way to do that. Now, once I brought that drawing in, I cleaned it up. Yours is in metric and mine's in imperial, so I scaled it down. I got rid of a lot of dimensions in liter and some of the text and that kind of thing, make it a little bit more manageable. And I made copies of the entities and brought them up here, and I put these entities in what we call smart layers, okay? I assigned them to smart layers, and I'm not trying to teach here, but I'm just showing you that Microvellum has the ability to set properties to the layers that these components are in that will do things like limit the sheet size availability and the material that's assigned to it. And so the parts will get broken up based on this. And I remember in our conversation, you said that a lot of what you had to do was drill holes and do, some encrypted stuff within your components in order the guys in the shop to know what part was what, to be able to identify it and to be able to know how it went together, because you weren't getting labels and that kind of thing for it. But what I did with the smart layers is I gave parts names as to where they occur within the product. So I'm able to do that as well, and I'll get those names in my part labels and whatnot. So that's what I did. I made, I broke this, made a copy of this. I assigned smart layers to it. And then I took this polyline and set it here. And I'm going to begin right now just to kind of show you. All I've got is a section, and it took me probably, I'm guessing about, to be honest, about 30 minutes to create the smart layers and then to assign these to the smart layers. I had to look at and measure all the material and know how thick it was, because that would make a difference as to what material I would use in that smart layer for the component and that kind of thing. And so once I got that together, once I made a copy of this and set it up here and assigned those layers to it, I can come in and I can add a product, an extruded product in here. And I'm going to call this my crown assembly and make this new crown assembly. And I'm going to assign it to this polyline right here. And so what it does is it brings in these components. Now, there's actually not any components in here now. There's some smart layers that are here, but I'm going to grab the extruded parts that are in this drawing, these components here, and it's telling me that I have the moldings are going to require bigger wood than what I told it that I had, but that's okay, because we're not going to actually cut it out of that anyway. And there you have it. That was pretty quick to build a model. So it has the ribs in it. It has all the components. It has this molding, which you're not going to buy that. You've got to create that. But you can see from this drawing, I mean, that was really, really fast. I'll go to a realistic mode. It'll help you see a little bit better. And that's about the size of that one member that was in there.
Pretty close.
I'll go back to an X-ray mode. And so I've got that. Now, what I'm going to do is I'm going to talk about a little bit about what you prepared to go to the router that you could glue up and then run the tilt shaper on. So I'm going to come over here and kind of set this stuff up, because I just made a copy of these and did the same exact thing. And what I did was I used your letters in here as far as the indication of what part was what. And so I'll just go here to products, and I'm going to right click and add, and we'll call this one crown stack. And I'll pick this line. And so I've got another product in here under the crown assembly, and I'm just going to do the same thing I did before. I'm going to grab these rectangles. They're just closed polylines. That's what they are. And there you have it. And so I've got a model in here that is exactly made from this section running on a path that I had given it to run on. So it doesn't really matter if it was, a compound radius, or if it was, a different shape, a rectangular straight line, if it was a bigger radius. Actually, I did these 240 inches and made like 600 parts to the crown piece. So, but I just felt like that was a little unmanageable for this meeting. So I felt like I'd go ahead and take that and break it down to a 10 foot, 120 inches. And as it turned out, that's actually the size that you guys made it. So I'm going to go to the crown assembly, and I'm going to show you some tools that we have actually to be able to manipulate these things in another part of the demonstration. But right now, what I'm going to do is I'm just going to go through this whole process of what I would do if I were using your section to create a model, a 3D model, and then I'm going to analyze it and save it as a product. So now it's getting ready to become a Microvellum product. It's not just a drawing. It's going to actually become a cut listed product here in just a few seconds. It doesn't really take very long at all. I mean, there's like, I don't know. It'll tell us in a little bit how many parts there are there, but I'm going to actually put this here. And so you and I both know, and I guess a lot of people that are in this meeting know, that the steps from here are pretty routine. I mean, from this point where I've got a cut listed product, completely cut listed, I've got names to parts based on those smart layers and the sizes of the components, the materials that are used, where they go in the product. I can actually create a work order now and go straight to the machine with this thing. Same thing's true with this piece. So what I'll do is I'll go to Crown Stack and I'll save that one. And it takes about, I'm guessing when I did this earlier, it was about 30 seconds to create the work order itself. And then processing the work order took me a little bit longer. Full disclosure, there's a lot of components here and there's a lot that the program has to figure out. But when I created the work order and went in and looked at it, the next step was just go grab it and make a work order. And when I go look at the stack, or when I go look at the crown assembly, I want to save a little time. I don't want to spend a bunch of time sitting here watching the machine run. It takes, like I said, full disclosure, it took about, I'm guessing 7 minutes to process this once I put it in. It took about, 30, 45 seconds to create the work order. But once I got it here, it took about 7 to 12 minutes, depending on which one it was. I think this one was about 12. The other one was 7 minutes to create it. And then when I go in and look at the optimization, there it is. And I've got true shape nesting. These parts are nested in here based on the settings that I have in the true shape nesting settings. They're not nesting in block nesting the way that your toolbox does, you know. This is actually what you had to do manually. And you can see that it indicates you've got this report. You don't have to plot nest anymore. This report actually gives you a reference number, an index that's in the drawing. It gives you a description. And when you look at the labels that come with this as well, also I'll just say that there's a master cut report here too. So you can see that it's going to separate the materials by the material, and it gives me a cut list of everything. So if I actually want to cut this offline, I could. And it'll tell me how many sheets I needed, you know, in my optimization summary for all of those pieces to be cut on. I need 7 sheets of 5x12 for that one. And when I look at the labels, this would be out at your machine, and you can pull up the sheet that you want, and you could use touchscreen. I'll keep my mouse down here and just use my finger to say, I want that label, and I can print preview that label. And it'll give me a picture of it. It tells me everything I need to know about it, and I can stick that on there. It even gives me an index here so that the guy that's got the printed report of the nest knows what part to look at and to put this label on, so it's identified all the way back. And, you know, this tells me that this is a cleat that's in section 4, and it's number 5, and there's about 7 of these per round. So that's pretty good. I've got all the information I need to send it out, and I've got my G code and everything. If I go
pretty neat, Ralph.
Yeah. Here's the code that would have went out to the machine. So yeah, I've got 7 codes. I got 7. And then this, if I needed to manipulate my drawing, I could. It actually creates a drawing in AutoCAD for the nest. So if you did want to come in and manipulate it, you could. And there's tools over here for manipulating the nest. So what do you think of that?
A little faster than I did it.
Yeah. So that'd be a great benefit, wouldn't it?
Sure would be.
All right. And the same thing was true with this piece. Now I showed you, get over here. I showed you this one, but this will be the same thing. It's just the same drill. I've got another work order that I created for that. And it's from Stack right there.
Rob, what do you think that would have saved you just on this one row crown molding?
7 minutes processing time versus 7 to 8 hours. I'd say about a 60-fold.
Okay, cool.
Brief question for you. Once you have that product, can you alter its exterior radius?
Yes, absolutely. Now I would alter it here in the drawing before I create it, saved it as a product. And if I need to, I can just erase this product. I can delete it. I can delete this product out of the job. And then if I wanted, I can go in here, and there's that polyline right there. So if I wanted to stretch it, if I want to change the radius, it's going to redraw it.
That's slick, Ralph. Because, we had to wait for field dimensions, and you know how high up we're getting field dimensions and how long that takes.
Yes,
and then
sir.
we have to go back and change the drawings and kind of not start from scratch, but it's a lot of time to do that.
Absolutely. I totally understand. So, yeah, just to change the radius of this, and you could type in, you could, anything you want. Actually, I can get rid of this. It takes so little time to draw it that I could get rid of this, make another, modify my polyline and come back and just tell it to make it again. So, also, editing the components that are here. You can do things to this that are going to update your piece. So when I drew that circle right there in the bracket, it added it to all these pieces. So if I need to add that piece of chase to get pipe or wire or something through there, that was pretty simple to do that. Even stretching the cleat. Let's suppose, for example, that I needed to make these cleats bigger. I mean, it's just the same thing. I'm modifying the drawing, and the drawing is updating, the section is updating my drawing. And then I could create the product from there. Questions?
The ability to edit those individual parts is almost as worth as much as the nesting capabilities.
Absolutely.
To have it update automatically like that.
I agree with you. I remember when we first went to the new platform, version 7 from 6.7, I was very used to using the very tool that you use to do this, the panel maker, where you could put down a panel the size you wanted and then begin to draw parts into it and then create code from it. And we didn't have that when we came to this new version. And I was like, man, I wish I still had that, but I would not trade this for that, not at all. And then plus I can still do that. I can still do that, but in a different way. Just using a tool in a slightly different way. So, you did something else, and this is something, yes, it will. I see that Jeff Lindquist asked, did it unwrap the vertical curve parts? It will. I didn't have any in here that were made by, if you do a curved tapered die wall, then it will lay those out in a frustrum, to use Kurt Schmidt's favorite term.
Favorite word.
Yeah, favorite word. So it'll do that in the nest for you. So, yep. For a conical shape. But this, I actually didn't try to make the crown here. I did the crown the way that Rob did it by stacking up these pieces. And then once these were nested in the nest using true shape nesting. And then once they glued these together, they could come in with their tilt head shaper and shape this out into the crown shape that they wanted. You did a courtroom thing too. And I'm going to go in here real quick and I'm going to open up a drawing that you sent me. The courtroom. Yeah. So you did this courtroom, and you did a lot of the same thing. I know you and I've known each other for quite a while, and I know how you work. You go in and you draw these things as a 3D model, then you bust them out and take the outlines, or I'm not sure if you use you draw over them or if you use a region or whatever, but the border of these components, these 3D parts, and you put them in the nest and cut them out. Is that right?
Correct.
Well, what I did was I took this witness stand right here. I guess this is a witness stand. And I tried to do something along with this. And I made a polyline that was 60 by 120. I just guessed at it. I didn't really measure it or anything. I didn't think that really mattered. You had another drawing that was in here that was the sections. And I took drawing. Right, this is another drawing, separate drawing. And I took this section right here and copied it to file, and I put it in here. I'm gonna pull this over a little bit. So I plopped that in here, and then I did away with some stuff I didn't need. I just wanted to use this, and I didn't actually put these brackets in. I could have those supports, the KV supports that were here. You can actually cause these to occur at interval around as well, but I was mainly looking to get this, and so I did a copy of the wall. And one of the things that I learned, I don't know what you do when you draw these, but I had to draw polylines over some of the entities that you had, and I did that, and then I assigned them to layers. And I didn't put, there was a reveal here that has a piece of laminate in it that I did not put in there. I just left that out. But I put there was a rail at the top, and it has hardwood edges on either side. There's there's a couple of plates here. There's a subtop, and there's a countertop with a subtop there. And then you've got these these vertical cleats or brackets or supports or whatever you want to call them. And
stretchers, typically.
Right, stretchers. I was trying to come up with that word. And so I did that, and then there's a couple other things I wanted to do. So I made some copies of the stud itself and made some changes to that and brought that in here. And this is our extruded product builder drawing template that comes in with the program. Whenever somebody downloads the new libraries, they get this automatically. And what it has is it has some examples in here, and you've probably seen Clay online demonstrating this before. And it has these parts are assigned to smart layers and whatnot. And what I did was I just created some additional smart layers in there and brought this in and assigned the smart layers. So I wanted to kind of show you how this is, some people consider this part of millwork as well, creating these fixtures. So I'm going to just err on the side of caution here, and I'm going to restart this program. And I'm going to come in and right click and add a new product, and I'm going to call this a witness stand. It's an extruded product. I'm not really trying to teach anybody how to do this. I'm just trying to show you there's different things that you can do to create different types of millwork and fixtures and that kind of thing. So I'm going to grab this here, and remember, it already has smart layers assigned to the components in here, and it's giving me some grief about a material thickness. Now that's actually a good thing. I want you to understand that the program is set up in such a way that it can warn you if you've got issues, if you created something that's not going to work. I've got a member here that's a different thickness than the materials I have available, and so, or the material that was in the smart layer. So it's telling me that, and I get the opportunity to fix that. I did a little something here too. Typically, and everybody that's used Toolbox in the past to do die walls knows that forever, the only way that you could make this transition in direction was to put the miter in the corner, and almost nobody builds them that way because it's too hard to ship it out this piece and this piece and get that to match up nicely in the field. So they end up going back and spending time transitioning this corner. And you can actually move this, you know, location. You can actually, using these custom tools, cause this joint to move down the line. You can control how the internal corner, how the studs, you know, relate to that corner, and whether or not, I want to just kind of come around here, whether or not this joint has a stud on either side or one in the middle of it or whatever. You can make it so that it leaves space at the end so you can scribe this off up against the wall. All kinds of things like that. So this is a tool that we have that allows you to create a reception desk that is much like the way that you would do it, or to create a fixture like this witness stand, the way that you would do it. And so from the section that I had, I can actually come in here now and just grab this product and tell it that I want to save it, if it's the way I want it. And adding circles, changing the wall, changing the diameter of a radius, or making that straight line turn into a radius. That's nice. You can do all of that. I'm going to set this out here. So we're actually using another component of the program called Solid Model Analyzer to analyze these solids. The solids were made using Extruded Product Builder, coming off of these 2D sections across that polyline. And once I have the solid, I can then convert it into a Microvellum product. And this is a Microvellum product. I can make these panels wider or narrower. I can change what kind of joinery I have in the corners to make the transition, increase reveals. This is an interval change. I told it I wanted a 1/2 inch apart, and that's what it did. And so I think they were 42 at a 1/2 inch apart. So it's pretty easy to create that, and then you can just go create a work order. And I don't think I have one. Nope, I don't. So I'm going to create a work order of this. I was going to. I don't guess it's behind anything here. Let me see. Nope. Oh, here we go. I don't know why it did that. So it looks at the way that I have this thing set up. It's using the project name and the room name, and I could add a suffix here if I wanted to, or I can leave it off. Either way. And I'm going to process it. So what it's going to do now is look at those components. And if I'd have gone to Edit Design Data, which opens up the spreadsheet, by the way, you have to export the project and go to spreadsheet in order to look at the components. I don't have to do that here. I can look at the components. I can look at the spreadsheet right here in the drawing. 79 parts. And we can come back and look at that in a minute if you like. Or I'll show you with another product that I'm going to do. And so then I've got all my components here, and you can see that I've got hardwood, I've got MDF, I've got this roughly 1/2 inch and 3/4 MDF, and the 1 inch, there's a 1.1811, and I called it solid surface. I didn't know what it was. I didn't really pay that much attention to what you had in there. So I'm going to select all of this and tell it to go to the router and apply it. And it's telling me here that there's parts of solid stock are not assigned to the processing station. So I'm not going to nest my solid pieces, but guess what? I could actually send code to a Tiger Stock to cut those parts off of. So I'm going to process it. You can see there's an X in the column for the processing station that we're using. You can have Chip all of your machines in the shop that receive code, whether they're horizontal bore and dowel machines or your flat table router or point-to-point, your saw, all that could be in here, and we can produce code to go to those. And this is done. That was all those components for that they're complete. I can go in and look at my nest, and all of my other reports, all the reports that you get, and you get a ton of reports with this, and I'm monitoring scrap actually here in this program. I've got scrap management as well. So that's my nest. And you know how you have to, Rob, print nest or plot nest, and then print those out to the printer. Well, these are 8.5 by 11 reports, and I don't have to plot nest anymore. It creates this report for me. I can go back and modify them. And I've got my labels for this and everything as well. Same as I did with the other stuff. So, questions?
Not yet.
All right. So that's a reception desk kind of thing. So what I'm going to do now is, I think I'm going to switch gears and I'm going to go to another project here. Recently, I worked with a company that purchased a software that does nothing but millwork, and they do entry doors and stuff. And I'm not going to give away too much. I'm just going to show you a product that I created that was an example, one of their samples, and I carried it to an extent, but I didn't do everything that they did, but I did use their construction methods. There's LVL material here for the main framework. There's you have the jambs, and you have the sashes for the doors, lights, and the transom. And what I did, the way I did it was I created the frames first. Actually I did the LVL, and then I created these things and saved them as sub-assemblies. And so I did the door first, the frame and the sash, and then I did the transom and the light. And if you look, and I saved them as sub-assemblies and then use them that way. And you can see that now this is taking a different tack. This is using it the traditional way of creating a parametric product using the spreadsheet method to create the product. So I've got my LVL posts and head and transom posts and that kind of thing. And so you can see the material. I created these materials in the material file and put them on brand new pointers that I made for this product. And that's the framework for the main door. And then if you go, like, for example, to the door jamb and show its parts list, you can see that this is the jamb. I've got the left and right leg and the head, and I didn't do a sill on that. And then I can go to the sub-assemblies of that. It has a nested sub-assembly, and I put the sash in there, and there are those components. And so I can create as many things like that as I want. Now, this isn't a cabinet, but parts are parts, okay? If I'm not going to, then what I have to think about, and I said this earlier when you guys were talking about, you know, when we were talking about you building the Oculus or in some of the other trim, I have to think about, what do I have in my shop to use? What are the processes for me creating these things? Are they CNC machines? Or am I going to use a manual process? Do I need to see a drawing of it or just a cut list? Do I need to have a buyout report? Anything like that. So the glass can be, I can cut the glass, I can optimize this glass. In fact, I did in my work order that I created. I can assign profiles to the panels or to the stiles and rails, joinery for the doors. If these were doweled into the doors, they could be laid, these could be composite, the doors that are built out of multiple units and pieces and parts. But this is a parametric product. Now, I actually could have, and I created these prompts in here with the additional tabs and stuff like that, with all these different options. So if this was going to be, for example, an 84-inch door that was 132 inches tall, I'm going to leave the sash and everything the same size as it was. So it's going to work like a cabinet does. It's going to do the same kind of stuff that a cabinet does. It's going to change size based on those prompts. I can turn things off and on, change what profile is on the door and all that kind of thing. So you just have to think your way through it. I could have made this using the solid model analyzer, could have modeled it in 3D just like you do, and then use the solid model analyzer, and it would have been a hard-coded product. So if I go in here and look at it, then I wouldn't see it in these red numbers. They would all be just simple values. And if I create layers in the AutoCAD layers that are the names of the parts, it'll actually put those names of the parts over here on the left-hand side as well, instead of just giving them numbers. I think that I had stuck that in there, and you can see that it's going to include the hardwood, the tempered glass, there was all kinds of stuff that's in here, particle board, just lots and lots of stuff in here. So, questions?
Not from here.
All right. How can you create a 2D drawing of this wall with dimensions for shop to build off of plan section? Oh, okay. So we're getting close to running out of time here. I could do that. Let's do, I'm going to do something that's going to work, I know, real quick. Hang on a minute. I'll do this.
So Ralph, that question is from Jeff. He says, how can you create a 2D drawing of this with dimensions for our shop to build off of, like an assembly sheet? So we have done some live episodes in the past where we showcase how to do that. I think we go into it about 10 or 15 minutes.
Okay.
Showcasing that. So if you wanted to get into it now, you can, about 6 minutes from the top of the hour. But we can also send a link there to that previous video where we showcase how to use those tools for the dynamic product images. Yeah. So yeah, definitely I appreciate you guys taking the time, Ralph, Chip, and Rob, for being here today. I think I can speak for everyone here in attendance. And I think Vince there, Foschini, also mentioned definitely impressive work with everything that you guys showcased there with the church, and Ralph, as well as some of those other products that you showcased. So thanks a lot for that.
You bet.
So as we have seen today, your Microvellum software, if you're a user and you're here watching today, your Microvellum software can empower you to do some pretty amazing things and go way beyond simple cabinetry. We saw there how Ralph was able to build that complex millwork that Chip was and Rob were talking about and showing those pictures, as well as that witness stand there from that courtroom. And what did you think about that entry door? Not too many people, they get so focused on the cabinetry and the millwork or the reception areas, but doing things outside the box, going into entry doors like that, definitely all examples of how you can do more than build cabinetry with Microvellum. So if you feel that you're not using your software to the fullest, maybe you want to bid on projects like what you saw today and want to learn how you can make your software accomplish those types of things, we'd be glad to help guide you to a better understanding of how it's possible. So just reach out to us, let us know that you want to be contacted, and we can definitely help you with that. Before we end today, I just wanted to mention a couple different things here. We are now 28 days from our TechCon 2018 event, our user group conference that's held here about 10 minutes away from our headquarters office here in Central Point. And I can tell you that this year has been exciting so far. We just, in fact, I just heard news a little earlier today that we just wrapped up our most successful quarter in our history. So that's definitely exciting. And that goes back from, I've been here for now, it's going on 18 years this year. And so to have that news, that's really exciting. We're growing, we're expanding to meet the needs of our growing customer base. And we're releasing new technology tools that are advancing beyond anything that we've had in the past. And this year's TechCon is going to be, again, unlike previous years. We'll be involving our user advisory members and having a lot of focus on building for the future, things that we're going to be working on, plotting out our roadmap for the future, as well as improving our user experience. But in addition to that, we're also going to have classroom training and one-on-one opportunities. So if you have not made plans to be here in May, you might want to check out that schedule and learn more about this event. So definitely something to consider. Also, if you've not subscribed to us on our YouTube channel, please do. That's how you're informed of future live events when we go live with our streaming episodes. So make sure that you do that. And on behalf of our team here at Microvellum, I'd like to thank you for joining in on the conversation today. And we'll talk with you again next week on our next Microvellum live event.